If you've followed my channel, you know I'm pretty skeptical about AI. I can't stand how tech companies hype up their models and agents just to boost profits without any concern for the truth or the real-world consequences of their exaggerated claims. But the downside of all this AI noise and shameless marketing is that we've become so tired of it that we end up ignoring tools that could genuinely improve our lives. The reality is that AI tools have been endorsed by a lot of prolific software developers in recent months, and even important figures like Linus Torvalds and DHH are starting to acknowledge their usefulness. One of my goals for 2026 is to take an honest, objective look at these tools and figure out whether they actually make a meaningful difference over time. Don't get me wrong, I'm not turning this channel into an AI fan club, but from time to time I'll actually spend a few hours testing a new model or a coding agent because, whether we like it or not, these tools are becoming a part of the landscape. That being said, a good understanding of all software concepts is now more important than ever, and this became obvious after I spent 2 days working with OpenAI's Codex agent and the GPT-5 model. It turns out working with agents is not at all what it is advertised, so on this Monday morning review, we look at what I learned after giving AI coding a fair fighting chance. To get started with Codex CLI, you simply install the dependency locally and then run the agent command in your working directory. For this test, I decided to go with a greenfield project, or in other words, a completely new codebase, so the agent wouldn't be biased by existing structure or conventions. I wanted to see how well it could scaffold something from scratch without hand-holding or context, but, if I'm being honest, having this first step of creating a basic project automated would make my life so much easier in the future. Like many of you guys, my GitHub is full of million-dollar startup ideas, which only failed because I spent too much time on the authentication flow or styling the admin dashboard. The project I decided to build is a native application that helps Brazilian Jiu-Jitsu gym owners manage their student classes. If you didn't know this about me, my only hobby outside programming is getting strangled by sweaty grown men at the gym. For the tech stack, I chose something I'm very familiar with on the backend so that I can easily evaluate the quality of the generated code. On the client, I decided to use React Native, which is a framework I used only for some small demo projects. This way, I could also determine whether I can correctly evaluate and modify generated code in a technology I'm not that familiar with. I started with a very generic prompt explaining in short the main features of the application and the technologies I want to use. What I found interesting is that the agent came back with some questions to clarify the requirements. It needed to know if I wanted the API to be secured with JSON Web Tokens and if it should use an in-memory database or something more serious. Of course, I went with JWT tokens and Postgres, and then I proceeded to wait a couple of minutes until the code got generated. I find it pretty funny that 15 years ago, when I started as a junior Java developer, I was working on a project that took like 4 minutes to build, so I was spending most of the day waiting for the compiler to finish. And now, in 2026, the peak dev experience is to wait anxiously like a junior dev, wondering if your changes will make the LLM do what you expected or not. Anyway, back to the code. Once the agent finished its work, I stopped the Netflix series I was watching and evaluated the results. Things looked really good on the backend, and the project compiled with no additional changes, but I guess this shouldn't be a surprise since there are tons of Spring Boot starter projects out there. The project was structured in controllers, which mapped HTTP requests, business logic was performed in services, and database operations were performed through repositories. Although some coding decisions were not exactly what I would choose, the overall implementation looked good. Authentication was correctly configured even though the publicly accessible URLs started with the auth path. This is more of a small caveat, but it's a reminder that these tools don't actually understand code. They are just black box machines that are really good at guessing word combinations. However, fixing this was an easy refactoring. The database entities also looked good, and I also got free DTOs out of the box, which, let's be honest, it's a pretty sweet deal. So the agent gets a 9 out of 10 for its initial scaffolding effort. Honestly, I was expecting the model to perform well when starting an app from scratch. After all, the internet is full of these Spring starter projects which were probably used extensively in the model training phase. But before moving to the React Native app, I wanted to give it one more specific task. It's always a good idea to provide a health or status endpoint for your APIs, so I asked the agent to implement one. My goal here was to see if the model knew to suggest the recommended Spring Actuator package, which provides these health metrics by default, and this was actually a failed test. The result was a newly generated status controller that exposed a public endpoint and returned the status directly. This got me curious, and I asked it to add a new line in the status response showing the API last deployment date and time. Its first suggested implementation was relying on an environment variable I was supposed to configure on the server. I discarded this suggestion and told it that there is no environment variable. The next suggestion was a method that fetched the date from a file on the disk. Again, I rejected this implementation because it was too complicated for no reason. Anyone familiar with the Java language and with Spring knows that the main class file is loaded only once in memory when the application is first started. You can easily define a static member in there and use it for our purpose. So while the initial scaffolding got a pretty high grade, once we get into some more nuance, the quality degrades fast. If you had no Java understanding, you would have picked the file or environment variable solution, and then you would actually create more work for you because you added an external configuration surface that now needs maintenance. This brings me to one of the main takeaways of this experiment. If you don't know what you are doing with the agents, you are basically digging your own grave with each code change you are accepting without fully understanding. It was easy for me to go with the file on the disk suggestion, for instance, then I would have needed a method to create and write data in that file. So, a one-line implementation could easily turn into 50 lines of useless code, and this is the sense I got for the rest of the coding session while working on the backend API. And the things were actually worse on the client. But before looking at that, here is your trivia for the day. While oil salesmen are acting like LLMs are a new revolutionary thing, the algorithms behind these models are largely recycled ideas from the mid to late 20th century. Neural networks, for instance, are a concept that dates back to 1957, and backpropagation, which is the primary way these models learn, was popularized in the 1980s. These were pushed to this absurd scale by the affordability of computing power, by training data availability, also known as data theft, and by big tech burning through billions of dollars like a gambling addict betting on Romanian second division football matches at the family Christmas table. Back to the video, the initial scaffolding of the React Native project was a worse experience from the beginning. While the logic to manage students, classes, teachers, and the schedule was all there, it was literally all there. In other words, it was all generated in one big TypeScript file with 1,000 lines of code. We are off to a great start. So after a few prompts to reorganize the code, I ended up with some basic tab navigation and the general screens I needed. Then, I jumped into the codebase, and the first red flag was the lack of code reusability. While all screens shared a header and some possible navigation buttons, they were all duplicated for each screen. So, I proceeded to ask the agent to do some more refactoring, evaluate the output, and then do some more refactoring. The whole coding session on the app was much more involved than it was on the backend. I had to explicitly ask for each view, and for each modal to be updated in order to not be overlapped by the keyboard, I had to always make sure code was extracted in reusable components, and I was forced to ignore a lot of nested containers and styling hacks just to proceed with the project. Now, to be honest, the result after around 20 hours of work is a completely usable application which will actually improve the life of my BJJ coach. A shitty quality app is better than pen and paper, so that's what really matters to him. And, if I'm being honest, I would have not been able to complete this project without code generation in this amount of time. One conclusion I recently reached after reading this amazing article about the industrialization of software is that for most people, bad software is actually far better than no software at all. And that's the uncomfortable truth I think we have to accept moving forward. A duct-taped React Native app that shows the class schedule without crashing will beat your clean architecture, your perfect abstractions, and your unit test coverage if you need months to ship the actual app. But also remember that I spent almost 3 full workdays to prompt and fix issues, and it took all my previous coding experience to turn the initial pile of AI slop into something barely usable. So, trust me, developers aren't going anywhere, and knowledge is more important than ever. Before wrapping things up, there is one more thing we need to address. Is this current model financially scalable? I pretty much abused the OpenAI servers for 2 straight days with probably hundreds of prompts, and all I had to pay was my monthly $25 subscription. In Rob Pike's words, I know that all this generated code comes at the cost of raping the planet and spending trillions on toxic, unrecyclable equipment. At some point, these companies will need a return on their investment, and if we'll have to spend $2,000 or even more to build the same app with agents, the story completely changes. As always, please abuse all the YouTube buttons possible, and until next time, thank you for watching.